I'm waiting for my grandson Brody to come over. I want to show him the new game I just finished. Oh, I think here he is.
Hi, Poppy. How you doing?
Good. How you doing? Come on in. Remember that game we were talking about?
Yeah.
Well, there it is. Take a look.
It's nice.
You like it?
Yeah. I like how like this goes to the hand, and I also like the collar too.
You want to play it?
Yeah.
Okay. You see that charger thing there? Why don't you plug it in? Put it on the side. And notice when you plug it in, see the screen there comes up?
Mm-hmm.
And it says level 1, and it says...
Try 0 and 0.0.
So there are 3 levels. One level like this, and then there's another level that this slide goes down further, and the penny goes faster. And then the third level, it goes all the way down, and the penny scoots right along. But you get 3 points for level 3. So what do you want to play?
Yeah.
Okay, there's a penny. You got to put it in there, and then you got to press the release switch and then catch it. After 10 tries, it'll move itself down. Up, there it goes. See it move down?
Wait, why does it move?
Now you're on level 2. Because you did 10 tries. You got it! Okay, give me a fist. Okay. Go ahead, keep on going. Oh, you got another one. How many points do you have now?
4.
Okay, go ahead. Oh, you got another one. How many points now?
6.
Okay. All right.
I got 11. My final score is 14.
Well, my best score was 21, so you did pretty good for the first time.
Yeah.
If you want to play again, what do?
Press the reset.
That's right, and then the game comes back and starts again. We don't have to play anymore if you don't want.
I want to.
You want to? Okay. Brody, are you still playing this game?
Yeah.
I guess you like it, huh?
Yeah.
This is the first of 3 sketches to align the servos on the game. This align lift servo sketch first attaches the lift servo to the Arduino so they can communicate. Then the Arduino tells the lift servo to move to 0 degrees, 50 degrees, and then back to 0. The next line waits for you to push the release switch, which is connected to the Arduino's D5 pin. It effectively stops operation so you can align the slide. If the slide is not fully vertical, you'll loosen the set screws on the 8mm side of the coupler to free the slide. Then you'll move it fully vertical and then tighten the set screws. Once that's done, you can push the reset switch. But first, we have to compile this sketch and upload it to the Arduino. We do that by hitting the right arrow icon and watching the messages on the bottom. Once the message says "Done uploading," execution will begin. When the slide comes to rest, start the lift servo alignment and finish by pushing the release switch. Note the slide moves up and down and comes to rest in the 50-degree game starting position. And that completes the lift servo alignment. This is the second alignment sketch. It simply moves the horn attached to the release servo up to 60 degrees and then returns it to 0. First, temporarily, remove the release servo's horn. Then, compile and upload. You'll hear the release servo move up and then down. Put the horn back on the release servo so its end is touching the slide. Load a penny in the slide and then press the release switch. The servo will activate, releasing the penny, and then come back to its initial position. And this completes the release servo alignment. This final alignment sketch lets you move the catch servo horn to catch a penny and then release it. First, temporarily, remove the catch servo horn. Then compile and upload the sketch. The release servo horn will move out of the way so you can insert a penny in the slide slot and move it to the catch servo. The lift servo will move the slide to almost horizontal, about 70 degrees. Now, move the penny next to the catch switch and reattach its horn so it holds the penny in place. Press the catch switch. The slide will go vertical and the penny should be held in place by the catch horn for a second or so before releasing it. If the penny drops immediately after the slide goes vertical, repeat the complete procedure by pressing the reset switch and make the horn tighter on the penny. Repeat as necessary until the horn holds the penny in place. And this completes alignment. I'm going to break this sketch up into 4 sections. In section 1, I've done a number of definitions and completed setup. The comments give line-by-line explanations, so I'm going to concentrate on more of an overview. Here we included the required libraries for the OLED display and the servos. We define the servos and the sensor variables. Then we initialize a number of variables we use in execution. Entering setup, we establish communications with the display. We describe what we want to appear on it, and then display it with the display.display command. We then attach the servos and move the slide to its starting position. In the second section, we enter the void loop, or main execution section. We call the display stats on screen function, which we'll discuss a little later. We then establish a go-to location. Some people say you should never use a go-to, but it works for me. We then zero a number of counting variables and initialize the release and catch servo horns. The next 15 lines keep track of a number of tries, scorings, and levels. The last of these 15 lines, while I equals 1, creates an endless loop at the end of the game and requires you to press the reset switch to play again. The remaining lines in this section process your pressing the release switch and get a random time for the release servo to wait before releasing. Finally, it waits until sensor 1 senses the penny. I call the third section Event Decision and Action Code, because this is where the Arduino determines if you caught the penny or not. Notice we have two cases. In case 1, a win occurs when the penny has cleared sensor 1 but not sensor 2. Anything else is a fail. Notice at the end of case 1 we go to go here 1, skipping execution of case 2. Case 2 senses if the penny goes through the slide and catch switch isn't pressed. It then does some housekeeping and loops back. The final section includes common functions. The first, sensor 2, is an interrupt service request ISR-based function. It will sense if sensor 2 is triggered regardless of what else is going on. Similarly, catch button pressed is also an ISR. I found both these functions needed to be ISRs for the detection of win and fail to work properly. The last two functions, play fail tones and reset, and display stats on screen, are straightforward housekeeping function. Well, that completes the overview of the game's sketch. Of course, you should do the 3 alignment procedures before loading, compiling, and uploading this sketch to the game hardware. Now, if you've gotten this far, I'd really appreciate your comments, a like, and sharing the video. If you'd like a copy of the 4 sketches, you can email me at brodafinjr@optimum.net, and I'll send them along to you. Until next time, when I create another project that Brody asked for, have fun with penny drop and catch.